Hi guys, it's Emily and I'm here with Mrs. Fortune, and I thought that I would present a lesson on area, that this is something that you could do at your house. It kind of ties in to the lesson on measurement that Mrs. Fortune is going to be posting today, which is going to be awesome. And it's never bad to practice these formulas, even when you feel like, I've got them down, and you could have some activity at home calculating some area of some of your rooms or your yard. Maybe this will give you something to do. So I'm going to be using the yellow material and presenting, and this is a review for many of you in the upper L, but it's still a worthwhile activity.
Hi guys, I'm just going to pop in here quick and say, third graders, you have all had this lesson with this material. I want you to review it. Second graders, you haven't probably had your hands on this yet, but go ahead and watch this, and you're welcome to do all the stuff that Ms. Searcy is ready to talk about. First graders, you can watch it too, no problem. But I will have a separate lesson that is more geared for first and second graders with measurement, okay?
Cool, okay, thanks Mrs. Fortune. All right, so what I have here is a rectangle, and I have the surface of my rectangle that I would like to measure. And I have at the edge, at the base and in the height of my rectangle, I have some little lines, and I'm going to see if those can help me figure out how to measure the surface of this rectangle. So let's see. Those lines are nice, but they're not going to help me so much. Let's see if these lines are going to be helpful. Oops, I drifted. Yeah, those aren't so helpful either. But here at the bottom, I have a rectangle that has squares. And so this rectangle at the bottom, I have a couple of things that I could do. I could count every single square, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. You could keep counting if you wanted. Or the other thing I could do is I could look at the number of squares that I have on my base. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And the number of squares that I have on my height. 1, 2, 3, 4, 5. And I could know from all of my experience here in the classroom that that means that there are going to be 50 squares on this rectangle. And the reason that we drive home this point about squares is because anytime that you calculate area, you're always going to record your answer in units squared. Whatever your unit of measurement is, you're going to square that unit, and you're figuring out how many squares would fit on the surface. So I can say that the area of this rectangle is 50 square units. That's really handy when I can count out all the squares. But what if I have a shape like this parallelogram? So on this parallelogram, sorry, I'll try to get that oriented, I can see a lot of squares that I could count, all of them. But then if you'll notice, I have these bits and pieces of squares here that are going to make it hard for me to keep my count. So I have something that might help us calculate the surface area of this parallelogram. Let's see. So here I have a parallelogram, and when I try to get that, sorry, it is congruent to my whole parallelogram. I'm going to take a look at what I can do here. Oh, I was able to make a rectangle. And now I can take the base times the height, and I can see that this parallelogram is also 50 square units, which brings it for the review of, for upper L, and for those of you seeing this for the first time, that I can say that the formula for calculating the area of a square or a rectangle or a parallelogram is base times height. Area equals B times H, which is base times height. So if you wanted to get a tape measure or a yardstick or anything that helps you measure, you could calculate the area of some of your rooms in your house, or if you wanted to go figure the area of your yard, or maybe you have a garden or a porch or a patio, those kinds of things. I'm going to go ahead and move along rather quickly to demonstrating the formula for area with the triangle. And this isn't going to go exactly how we would do it in the class, guys, because we don't have that time, but I think it's going to work for you seeing the material. And if you have any questions, you can send us an email and I could follow up that way or re-present just like we would here at school, because repetition is our friend. Okay, so I'm going to clear these things off. And we're going to talk now about area of a triangle. And I have here an isosceles triangle. And I have that same problem or difficulty that I had with my parallelogram, and that I have some whole squares that I can count, but I also have these little bits and pieces, and those bits and pieces are all different sizes, so I can't tell how I would count those up. So I'm gonna see if I have some material here that will help me out. Can I pass that to you? I'm trying to, oops, you're getting oriented to the, all right. So here, I have the same triangle, but it is in two pieces. So I can just confirm that it is congruent. Congruent, that's a good one. And I'm gonna see what I can do. So here I have the base of my triangle, and I'm going to cut that in two and then see if I can make a rectangle. And so I can count my base times my height and see that the area of this triangle is 50 square units. 1, 2, 3, 4, 5 times 10. Okay, but let's take a look at if my triangle were cut up or arranged in a different way. So here I have my same isosceles triangle, right? And it is congruent. And here I have my height. And let's watch from the video. I have a rectangle. And I can take my base times my height. I split that height in two, and now I can see that it's 50 square units. The other thing that I could think about doing is I could take this whole isosceles triangle and these two pieces, and I could double my triangle, right? And take my base times my height. Here my base is 10 and my height is 10. And so we all know that's 100. And this is for two triangles. So if I divide that in two, then the area of this one triangle will just be 50 square units.
What? No way.
Okay. So you know what I think I'll do, guys, is show you the formula with this triangle at the end after we've divided all of these up. So we're going to take a look at a couple of different kinds of triangles, and then we'll do the formula with the tickets at the very end. So thank you for your patience as we figure this out. Okay, here I have a right-angled isosceles triangle. And it's a right angle triangle because it has one right angle in it. Hooray for right angles. Okay. A similar situation where I have whole squares that I can count and the bits and pieces. And I'm going to see if some of my material here can help me. So here I'm going to just establish that these are congruent. Okay. And here is the height of my triangle, and I'm going to split that in two. And I get that amazing rectangle again, where I can take the base times the height and see that the area of this triangle is 50 square units. And if my triangle were oriented this way, so that this were my base, I'm splitting my base in two and turning this into a rectangle. Take it base times height. All right, let's take a look at an obtuse angled triangle. Let's get crazy. All right, I have an obtuse angled triangle. It has one obtuse angle. Same problem. I have these whole squares and then the little bits and pieces. So I have this, help me out. I'm going to establish that they are congruent. They are. And here on this triangle, my height, oops, sorry, get that in the frame for you. It's all backwards. My height is external, okay? So I'm going to cut my height into 2. And I have a rectangle, right?
Ooh.
And I can take the base times the height. Or if my triangle were oriented that this were the base, I'm cutting my base in 2 and making this a rectangle. So we did the same thing with all 3 of these triangles. I'm going to go back to the first triangle that we used to lay out the tickets and to show you the formula, because honestly, it's the one that I have the easiest time lining up in the screen. So hopefully I'll get better at this as we go along. So I'm going to lay out my tickets that I have area of my triangle. Is that right? Okay.
Can they see those tickets?
If they can't, I'm just going to show how we're dividing it this way. And here I have my base. I'm labeling my base. Oops. And here is my height, right? And what I've done is I've divided my height. I've divided my base in 2. So I have area equals the base divided in 2 times the height, right? Or I could talk about it with dividing my height in 2. And really what you can say is that area, sorry guys, a triangle is base times height divided by 2. So I have it written here on the whiteboard, a little bit larger for you to see. The area of a triangle, any kind of triangle, is base times height divided by 2. And then to remember that you always record your answer in area in units squared. So if you have decided that you're going to go make a giant triangle in your yard and then measure it, and you're measuring in feet, then your answer will be in square feet. Or if you're doing it in yards, it'll be square yards. So that's it for today's area review or lesson. I hope that this gives you something that you could do at home, a little math to practice, and we'll be in touch again soon. Thanks for your time. Bye.